The t-test should be done when the dependent variable is continuous. Examples of continuous variables include temperature, hemoglobin A1C, height, and many more, of course. Continuous variables can always be measured with more precision, more decimal places. Continuous variables have averages, or means, standard deviations, and the variable can be distributed on a curve. The t-test is fundamentally to answer the question, is the distribution of this variable similar between two groups? To put this question into numbers in the language of biostatistics, we ask whether the average or mean is the same between two groups. In order to meaningfully interpret the difference between these means, we need to modulate our calculation by the amount of variability within our groups, which is captured in the language of biostatistics using standard deviation. We also need to modulate our calculation based on the sample size, since variability is more unpredictable and has a larger proportionate effect in smaller sample sizes. If we have more than two groups, i.e. we want to compare the means of three or more different groups, we use similar concepts, but there are additional considerations in calculations, and we use different tests. The concepts that underpin that type of testing is the same as the t-tests, but they're beyond the scope of this brief and straightforward summary video. To give an example, the t-test could answer, do males and females weigh significantly different from each other? Of note, we're not answering whether any given male or female weighs differently from one another, only whether the average of the males and females in our sample group are significantly different from one another. Here's our data with 7 males and 7 females. When you enter this information into the statistical program of your choice, you get the following calculations. For males, the mean is 87.14 kilograms. The standard deviation is 23.67. The sample size is 7, as we've discussed before. For females, the mean is 85.14 kilograms. The standard deviation is 37.95 kilograms, and the sample size is as above. The p-value is 90.78%. Remember that the t-test is a comparison of the means between two groups. Our question is, do males and females weigh significantly different from each other? Our null hypothesis is that they do not. Given that the p-value is so high, we cannot therefore reject the null hypothesis. So we cannot say that males and females weigh significantly different from each other based on this sample group.